So, back with Kevin again. So we're going to talk about a couple things in this next part. We're going to talk about, well, first we're going to show you some of the beginner documentation that Python.org offers, and then we're going to get into things called data types. For right now, I want you to go ahead and create a new file and save it as lesson2.py wherever you saved your lesson 1 file at. And so you should have a blank screen in front of you. So I'll go ahead and bring up the documentation. So if you go to python.org, this is where all the documentation for Python 3 and 2 exist. You can look at the documentation, and there's actually a pretty cool beginner's guide here that you can go ahead and follow. And it'll show you all these quizzes and exercises, and these are just extra resources that you can use. Like, let's look at beginner guide example. When you're learning, small examples can be very helpful. So let's see. Look at all this stuff. Look at all this stuff. My God.
Yeah.
Is there anything specifically you want to speak on documentation, Kevin?
Well, I want to speak on why it's imperative to review the documentation, because Python may have, well, the creators of Python might have an update. They may, make bug fixes, what have you, and they put the updates on the documentation page. So that's why, as you can see, the list of the versions is great to review the versions every now and again to see what's changed in Python, if there's a new version, if some of the data models might change. So review the documentations every now and then just to stay up to date with Python. Make sure you're not writing code that no longer exists or has been replaced in Python, and et cetera, et cetera.
No, that's a really great point. So I can think of an example right now. In PowerShell, there's a library of SQL commands that talk to SQL servers that Microsoft has overwritten with new commands, but not really told anybody, and simply just updated their module without updating the documentation. And so now we have a bunch of old SQL commands that no longer work, but we have code that has those SQL commands, and we had to go back and we had to change all the SQL commands to the new updated versions of them. So you'll come across that every now and then. So I'll put the link in the description for where you can find the documentation for Python specifically. But this, as Kevin said, this goes with any language you're working with. If you're working with Java, go review Java docs. If you're working on front-end stuff, go to Mozilla Developer Network. If you're dealing with jQuery, go to jQuery website. Make an effort at least once a week while you're either on the train or you're waiting for somebody to go on your phone and look to see if there's anything coming up, or if anything changed dramatically that's going to affect you.
Right.
Part of being a developer is you're always developing. You're always working, so to speak. You're always checking to make sure things are stable, right? Because your programs rely on these languages. Okay, so we are going to talk about data types. And we're going to talk, again, this is more pointed at the beginners. We're going to talk about two data types specifically. We're going to talk about strings, and we're going to talk about numbers. Okay, so if you remember in the first lesson, we wrote a message that said something like, my car is, colon. If you notice, it's between double quotes. So a string value, or a string, is anything that's in between quotes. Now in Python, you can use single quotes, and it will have the same behavior, right? But what you should remember is just be consistent. If you're going to use double quotes everywhere. If you're going to use single quotes in Python, use single quotes everywhere. Don't do double quotes here and then single quotes there. It'll get confusing. So it doesn't really matter which quotation system you use, just be consistent. So a string stores characters. So let's go over a couple of examples of strings. So an apple can be defined as an apple string. The word one can be described as 1. Now, this isn't to be confused with the actual number 1. It is the character 1 on your keyboard. It doesn't represent 1 numerically. It represents the string 1. So it's just a message. It doesn't have a numerical value. I can't take 1 and add 3 to it or add 2 to it, right? Because if you try to do that, it'll say, wait a minute, 1 is a string, not an integer or number. You cannot add a string and a number together. They're not the same data type. Now, what's interesting is in Python, you can add the same data types together, and that's called concatenation. And so when we rerun the program, hit F5, 1 plus 1, the variable. Save this and let me clear out my terminal and rerun it. Let's see what it says. I should probably print out the statement, right? Because we need the computer. We need the computer to respond back to me. Okay, and it prints out 11. Well, no, it's not printing out 11. We see it as 11, but what it's actually printing out is 1 plus 1 is equal to the characters 1, 1. Just like if I were to say print 1 plus the word happy plus 1, right? And I were to run this, it would say 1 happy 1 because it's reading the number 1 as a character because it's in between the quotes, and that's what a string is. Kevin, you have anything else?
No, that's pretty straightforward.
Pretty straightforward. Let's move on to numbers then. Okay, so let's talk about numbers. So numbers are a little bit different. So in Python, we can do all types of math. And we can store it in variables. So I'm going to create a variable called total. And it's going to be equal to 1 plus 1 minus 1 times 1, okay, divided by 1. So these are your basic math operators that they exist on calculators. They also exist in Python, and you can just run them directly into numbers. Now notice I use the number 1 without quotes, and what that does is it allows the computer to recognize that I'm now using something called an integer. And an integer is defined as int, is any counting number. So from 0, 1, 2, 3, 4, 5, if you can count it in real life, like I have 1 Gatorade or I have 5 apples, that is a counting number. You can also count negative numbers. So a -1, -2, -3, these are integers. Okay, they're whole counting numbers. So let's print total.
Yeah.
So when we print total, we get 1.0. We'll talk why 1.0 comes back. So with integers, we can express mathematical terms. So what I mean by that is that we can operate, any math operator works the same in algebra as it does in Python. So if you remember, there was a what's it called? A mnemonic called "Please excuse my dear Aunt Sally," right? And what this means is it's parentheses first, then exponents, second, then multiplication third, then division fourth, then addition fifth, and then finally subtraction. And so if you know basic algebra, it works the exact same way. So let's redefine total is equal to 1 plus 1 minus 1 divided by 1. Okay, and then we'll print out total. And the first total will be 1.0, and the second total is 1.0. But let's say we'll change the plus to multiplies, and we get 0. So when I use mathematical terms in my coding, I always use parentheses. So even though this is 1 divided by 1, I'll still put it in parentheses because I want to understand that this set of operations is happening within these parentheses first. Then I'm using a mathematical operator on it. Then this set of parentheses is being worked on at the same time that the first set. So before these two terms get subtracted, the 1 times 1 triggers first, the 1 divided by 1 triggers second, then they're subtracted from each other. Okay? That's how basic math operations in integers happen. Kevin, you got anything on integers? But
I think, well, in Python, and I think specifically Python 3, there's no limit to, I think, how long an integer can be. So you can have, 10 zeros in your integer value times another, 10, 9, 11 zeros, and it'll print that exact value.
Yep.
And Python interprets the decimal digits without any prefix to a decimal number.
That's correct. So what's also interesting in Python 3 is that it will first convert an integer into a float and then attempt to do the math on it. So in previous versions in Python 2, it would just round. So if you had 2.5, it would round it to 3 and then multiply it by 2. So if we did this operator here, so I'm going to put Python underscore 2. If you had 5.2, okay, times 1.3, it would literally look like 5 times 1, even though that's incorrect.
Right.
Right? And let's put this in quotes so that way it's a string. In Python 3 is able to do the math on the floats. It's in Python 3, if I have let's do 5.6, or let's just keep it the same. 5.2 times 1, in Python 3, what it does is it does the operation 5.2 times 1.0 before it does the calculation. So it will so Python 3 converts your integers into floats. And speaking of floats, let's talk a little bit about a float. All a float is a decimal. So let's talk about an integer. An integer, this is an integer. A float is, we'll misspell float so that way we can use it. A float is just adding a decimal places. So when we talk about floats, we're talking about decimal places. There's nothing fancy going on here. But what we need you to understand is that when you're doing math operations inside of Python, Python will recognize an integer. It will then convert it to a float. And then it will do the addition, subtraction, etc., on it. Okay? So moving past floats, let's talk a little bit about another math operator called modulo. So the modulo is a very interesting operator. What it represents is the remainder. So in school, when you did division and you said my total is equal to 5 divided by 2, when we did this at school, you do long division and you would say, okay, well, that's 2, 5 divided by 2 is 2 remainder 1. So in Python, we can do the same sort of operation, but instead of putting the division symbol, you put the percent sign. So let me comment out our print statements up here. And let's print my total. Okay, so we're going to print my total, which is 5 divided by 2 first. And then I'm going to print my total, which is 5 divided modulo 2. Okay, and I should make it correct. And that's wrong. And F5. Yeah, else while scanning literal. Oh, because Python 2 right here. Let's comment these out. Just get rid of them. We don't need them anymore. Alright, F5. Okay, so 5 divided by 2 without the modulo, meaning just using the divisor symbol, gives us back 2.5. 5 modulo 2 gives us back 1 because 5 divided by 2 has a remainder of 1. Now what this is really good for is finding odd numbers, right? So let's have a list of numbers called mylist. Okay? And in this list, we'll have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's print out my list. Let's print my list. Okay? Hit F5, run it. It prints out this list. And I wonder if I can just get rid of these braces. Let's see what happens when I get rid of the braces. Yeah, okay, fine. That works too. So what I'm going to do is I'm going to delete these terms here, and we're just going to look at my list. And so I have a list of numbers between 1 and 9. Now, if I want to find the odd numbers, I know that an odd number can never be divided by 2, right? So I would write a function, okay, we're not going to write a function now, where the function would take the current iteration of my list. So my list, it will take the first position 1, and then it would modulus it by 2. And if that were to equal 0, then I know the number's even, because 2 divided by 2 gives no remainder. There's a remainder of 0. 3 divided by 2, so let's print 3 modulo 2. Okay, that gives us a remainder of 1. So I know that odd numbers when divided by 2 will have a remainder, and I know even numbers when divided by 2 will have no remainder. So that's how you're able to identify even numbers and odd numbers. So that's where modulo becomes useful. Modulo becomes useful when we're looking for patterns in a large list of things. Anything you want to add there, Kevin, with modulus? Or modulo?
I'm not really too keen with the modulus.
It's used in algorithms. We're going to see them later on. We don't need to. You need to know they exist right now. You don't need to go too far with it yet. When we start writing functions and stuff, we'll revisit the modulo.
Yeah, I may have to rewatch the video for myself.
Yeah, it's just a remainder. It's a fancy way of saying remainder. I have remainder this. I have remainder that. Okay, so let's talk about another operator called the plus equals operator. Okay, and we have this variable here called mylist, and if I wanted to update the list, the old school way, you would say mylist is equal to mylist plus 10. right? And then if we print out my list, oh, exception is carried in my list. Can only concatenate a tuple, not into a tuple. Ah, I see. So when I defined my list, it made it, we're gonna change list to a list of strings like apple and banana. And then we're going to get rid of this. I'm gonna rerun it. CLS F5. See if we get an error. Nope. Okay, so now I have a list of apples and bananas instead of those numbers that we had. So just update your code to hold these two strings. And what we're going to do is we're going to update my list with oranges. Hit F5. Nope. So apparently we cannot do that. It's seeing it as a tuple, and I think it's seeing it as a tuple because I don't have it surrounded in parentheses. But let's see. Nope, I have to put it in brackets. I think that's how we declare arrays. I don't know. We'll see. Let's F5 it again. CLS it. F5. Not letting us create a temporary dictionary. Anyways, let's just try to update it with the plus equals operator. Let's see if that works. Huh, it doesn't let us do that. That's all right. We'll do a different example.
What were you trying to do?
So I was trying to update a variable. So we can do it mathematically, right? So instead of updating a list of things, we can start with a number. So let's start with a number that can change. So let's say students is equal to, we have 16 students. We just got 4 new students. So before you would say students, to update that variable, you would say students is equal to students plus 4. So let's say in the comment we say we have 4 new students. Yeah, right? And then we print out students. Okay, and we expect to see 20, right? Because we had 16 students and we're adding 4 students. And you can see that it prints out 20. Well, what the plus equals operator does is it removes, pretty much we don't have to do this statement here, this equals students plus 4. We can just do plus equals 4. And then when we print students, we get 20. Okay, so right now let's comment all this out and let's write ourselves a little application that demonstrates this. And in this application, I'm going to put order of coffee. Okay, and I'm going to create a coffee price. And I'm going to say I'm charging $1.50 per cup of coffee. Okay, and I'm going to print out a cup of coffee costs whatever the coffee price is. Okay, we're going to create another variable called your order. Okay, and let's say you order 2 cups of coffee. I'm going to print out let's see, you have ordered your order plus cups of coffee. Okay, so we're going to create something called your total is going to be equal to whatever the coffee price is, right, times how many coffees you've ordered. So we're going to restructure this. We're going to copy and paste this. And we're going to put this up at the top. Because what we want to do is we want to separate our variables from our print statements. So we're saying a cup of coffee costs whatever the coffee price is, and you've ordered however many your orders cups of coffee. And then we want to print out your total is going to be whatever your total is. Okay, so we have a very simple coffee cup program. So what we can do is we can change these variables, and we expect to see these pieces here change. So what's interesting here is we have a problem. We have a string, a cup of coffee cost, and then we have a number called coffee price. Now, if you remember, I told you we cannot add strings and numbers together. So Kevin, how do you think we get this message to print out? Because if I try to print this out right now, it's going to throw me an error, right? It's going to say, wait a minute, you can't add a string and a float together. You can't add a string and a number together. They have to be the same. So how do we make these things the same? Or what is the logical thought process about getting this message to print out?
Wait, I gotta tab back over to the screen.
Slagging.
All right.
So I can't add a string and an integer together, right? It just
Okay,
can't happen.
price.
So then what do I need to do to coffee price to make sure that this message prints out? Because if I try to run it right now, it's going to throw me an error that says can only concatenate string, not float to string.
So what if you make coffee price a string?
So that is correct. So in Python, we can convert things to strings when we call it. So even though coffee price is a number, if I put str and I surround coffee price with parentheses, what it will do is temporarily convert coffee price into a string to allow this message to work.
Nice.
So I'm going to do that for each of these numbers. Now, when we get more advanced, we'll just create a function that does this. We won't be having to do this in every single line. But now, if I print out my message, it says a cup of coffee costs 1.5, which is not really what we want. You have ordered 2 cups of coffee. Your total is going to be 3. Okay, so there's a couple things we can do to clean this up. First, when you're writing and concatenating strings, you want to add a space in between the last character in the quote. Okay, and then on the other side of the concatenation, between the quote and the first character, you want to add this space here. And as you can see, that'll generate the message to look normal. If you look, we didn't do that on the last line. And the colon is right up against the 3.0, which is not what we want. So I'm going to add an additional line here that says dollars. And then what we can do is we can now change our price of coffee. We can say, okay, coffee now costs $3 per cup. We're Starbucks now, right? We're going to charge $4 per coffee, and you're going to order 2 coffees. And so we'll rerun the program, and now it updates our amount due to $8. So strings and numbers work interchangeably. You have to convert one to the other. So the easiest thing is to convert everything to a string, right? You can't convert a cup of coffee to a number, but you can convert the number 1 to a string.
And did you mention that you can make that a function itself that by converting the number to a string? No?
I don't think I did. I did
Okay.
say that in the future we'll use functions to do this.
Oh, okay. In the future, we use from.
Yeah,
Okay.
instead of repeating ourselves of converting this. Now, what's interesting is if you just because we converted it here to a string, it stays an integer. The variable itself doesn't change the type. So if we call coffee price, if we say print uh, coffee price plus, we're gonna raise it another $2, right? If we look, you can coffee price comes out as 6 now because it's still a number. But inside of the print statement, we're temporarily converting it at the time that we see it to a string. So these values don't change, but this little guy here, this converter, it's called a method, allows you to temporarily convert it. Doesn't change coffee price to a string inside the variable, but inside the print statement, it changes the variable temporarily into a string,
Hmm.
which can be confusing, but we'll move on. So moving on, let's talk about really quick. I think the last thing I didn't mention was exponents. Exponents in Python, super simple, man. Uh, my price is equal to 5 to the second power, right? And that should equal 25, right? So if I print my price, and let me turn off the print statement for coffee, I get 25 down here at the bottom. Let me CLS that actually. Let me bring up PowerShell because it looks a little bit cleaner on PowerShell. Uh, was it exit? Was it exit? Exit? Yeah. CLS. And then let's run Python lesson 1. Oh, we still have car. I didn't save the file. Let's rerun the program. That's still. Oh, I have lesson 2. Duh. Or lesson 2.py. And a cup of coffee is $4. You have ordered 2 cups of coffee. Your total is going to be $8. And then look down here, it prints out 25. So exponents are just 2 multiplication symbols next to each other. So whatever 20, so that was 125 if I raise it to the third power. Let's see what it does. I think I broke my terminal. Let's try to run it. Run PowerShell again. Yeah, 125. So anything on numbers or strings that you'd like to add?
No, we can keep it simple. That was good.
If you guys have any questions, just go ahead, hit me up on the Discord server. Remember,
I,
floats are decimal, integers are counting numbers, strings are things that are in between quotes, and you can convert floats and numbers into strings. Anything you want to add, Kevin?
um, what about square roots?
Square roots. I don't think
Yeah.
we need to deal. So oddly enough,
Out of the scope.
yeah. So square roots. That's a great question, actually. Um, I do have a function that we're gonna be building to find the square root of things. That's later on. That's after. That's right before we do our graph algorithms. But essentially, a square root, you either have to install um, a math package, and then you can square root something by typing in like square root of this number, and it'll automatically do the math on it. Or we'll create the function, and the function will go and do the square roots. So that's something that we're gonna do in the future. We are gonna visit square roots. It's very fun, I promise you. I know some people may think math is dull, but when you start programming, you're gonna realize that you don't have to memorize formulas. You just have to memorize how to code it. And once you understand how to code it, you'll understand how the math works, and it'll sort of open up mathematics for you. I'm not a math guy. I became a math guy once I understood how to code, because it made mathematics a lot easier to learn even in my old age. So if you have any questions, let us know. I'll put those links in the descriptions for the documentation for Python.
Yeah.
There's a whole beginner stuff. There's other resources you can look at. So just let us know. Thank you.